This video shows how we installed an EV charger out near our driveway parking area. It's about 50 feet from the house. If you're lucky enough to have a garage with a breaker box in the garage, it's much simpler. This required running some conduit and ran into some issues, but just want to share with you what we did. I think if you're considering this, you should watch this video. This is the charging station with our Chevy Bolt EV, and I'm going to first show you how we use it, and then we'll show you some more detail on how I put this thing in and installed it. We installed both a 60 amp 240 volt circuit for the ChargePoint Home Flex charger and also a 120 volt 20 amp circuit for an extra receptacle to run our level 1 charger off of, and also to power a motion activated light that we added to the pole. This is a ChargePoint Home Flex charger. The light shows green there when it's ready to charge and good to go. I'm going to show how easy this is to put this thing on charge. This bolt. I'm going to stop here, put it in park. Set the parking brake, turn it off, get out, push right here to open the charge port, grab this, plug it in, and it's working. The motion activated light is well worth it when you come home late at night, as you can see in this little video clip. Light comes on, makes it real convenient, easy to see, and very simple to plug in the charge port. Hey honey, just recording what it's like to come home and plug this in. So putting in a motion activated light out here where you charge cars makes it much more convenient. That is, the light itself is not motion activated, it's the bulb. Because that way if it goes bad, I just replace the bulb. Don't have to replace the whole fixture. Okay, some important information. This is basically a disclaimer. I'm not a licensed electrician. I cannot advise you on your project. But I am a fairly experienced do-it-yourselfer. You should hire an electrician if you can, because your situation and house design is probably different than ours. I'm sharing this project information with you to help with your project planning. Our local county building codes required me to obtain an electrical permit, and I did have to sign a document stating that I was doing the work myself and would assume responsibility for the project and plan to live on the property. It did pass inspection, and the charger does work great. Now, if that post looks like it's leaning, it's because it is. When I took this, I had not finished packing in all the dirt, filling in the trench and all that, and straightening it up. So it's not totally shoddy work, it's just that part of it was not quite complete when I did this video. I built that housing out of one 2 foot by 4 foot piece of 3/4 inch treated plywood. Just made a slightly sloping top to it and got it mounted to a 6 inch by 10 foot treated wood post. It's about 3 feet of it in the ground. I've got a standard just outdoor light fixture up top with a motion activated bulb. That way if it goes bad, I can just change the bulb, don't have to change the whole fixture. And of course, I've got all of our cables running conduit You can see where it's hooked up 3/4 inch coming out of that. It's 6 gauge cables, 2 hots in the ground. I got it going into a what they call a T-body, because it goes this way and that way, and I got that reduced down to 3/4. That's reduced down to 3/4 to here and down to a half up there, going up to the top to the light fixture. I ran 1.5 inch conduit all the way to the house, and this is also a 12 gauge wires run to this. It's a 20 amp GFCI receptacle I can run our level 1 charger off of, and which I do sometimes. That's the only thing I don't like about this ChargePoint charger, is there's not an easy way to reduce the current. We've got a 60 amp breaker and it runs at 48 amps because of that, which is good for charging fast, by our standards, by level 2 standard. But if I want to charge at a lower rate just to save the battery, there's not a good way to do it. You have to, without going into a long story about that, let me just say I can't find an easy way to do it. And I've got another level 2 charger which is portable. You just plug in the current limit you want. It's easy. This, they call it flexible, but that's the only thing I don't like about it. Other than that, it works good. And of course, this is our trench where we put our conduit in. I dug it over 18 inches deep. I had a little problems making this bend here, so I'm gonna have to cover that with a little more dirt, make sure it's 18 inches under. That's a yard hydrant I put in. I went ahead and put some 1 inch PVC water pipe in there to, might as well take advantage of the trench while it's dug and make it easier to wash the cars. And this is, I've already covered up this part of it. That's where the conduit goes in under the house, and we'll go down and look at that. Okay, behind that, the white 1 inch water pipe I've got going to the berry hydrant down there. That's where that goes. I had to dig in under the foundation because the water line has to be below the frost line, which around here is supposed to be about 12 inches. So it's well below that. The conduit, on the other hand, just simply has to be conduit, since we ran single conductor THHN/THWN dual rated conductors, wires. I ran this 1.5 inch conduit. You can see there all the way down to, you see it up there. Had to come underneath that other conduit. It goes up to where our breaker box is, to that L body right there. Those L bodies you need things like that for pulling your wires. That can be a bit challenging. So we'll show you what it looks like up at the breaker box. Okay, I cut this opening, drilling a bunch of holes. This is plaster, by the way. It makes it a lot more difficult than drywall. See all that blue down there? That's a 3M fire block sealant. So you don't want any fire that develops in the under the house to easily come up to an opening, so that should be sealed. That's my 1.5 inch conduit, came up from underneath the house. I was able to fit it behind this. This is just a 90. This is rough cut wood, so a full 4 inches made it a little easier to be able to bore a hole through there and to a knockout on this side of the breaker box. Now, if you can see, there's this black, red, and green wire are the 6 gauge, and the black and white are the neutral and hot. And there's also a green, you can see it, it's dark green right there, 12 gauge for that 120 volt circuit. Now this panel box is a square D, I think it's called QO or something like that, but it's over here on the left. Yeah, it's like QO load center, I think. Even though there's 30 single spots here, it says I believe there's 40 individual circuits allowed. So what happened was I only had one single spot here. So what I had to do was install two 20 amp tandem breakers, and that made room for this. It gave me room for one of the for the 12 gauge running out to the power pole out there, the charging post, and it made enough room for this dual pole 60 amp breaker for the ChargePoint. It was really tough fitting in everything here, but I managed to get it in. And by the way, this area, electrical permit was required to do this, and it passed inspection okay without any issues. So it works good. The only issue is these things are expensive. You know, the alternative might have been putting in a sub panel or something. I decided just to go this route. And now the ChargePoint instruction manual, they tell you probably shouldn't put in a GFCI main breaker there because it can cause erroneous trips. So those tandem breakers were expensive, about 80 bucks a piece. And I don't remember the exact price on the 60 amp breaker, but it was at least 40. So you're looking at roughly $200 just for breakers. That's how I did this, and works real well, no issues. I want to point out that in the ChargePoint installation instructions, they require a licensed electrician to do this work. And I don't blame them because electrical work is hazardous and dangerous. I'd done enough electrical work, I wasn't concerned about doing it myself. I didn't want to do it myself. In fact, I got a quote from a licensed electrician. They came out and looked at the project, and it was too expensive. I decided I could save $1,000 doing it myself. But basically I did the same thing they quoted, only I put an 1.5-inch conduit. They were going to use 1.25 inch. Everything else pretty much the same. But just keep that in mind. That is in the ChargePoint installation instructions about using a licensed electrician to do your project for you. This was inspected under a permit, so I'm pretty comfortable with what we did. Okay, this is the ChargePoint charger with the cover off, showing how conduit comes up here. This was 3/4 inch conduit, and I've got 6 gauge THW, well, it's THHN/THWN-2, so it's double rated for conduit and in wet applications. This is the way the wires are hooked up going to the charging cable. You have to kind of pay attention to what you're doing here because they call for the ground here in the center of the incoming cables. Of course, the red or black could be on either side of the 240, and then now the ground on the charging cord, that's this one right here, is on the left side, so you do have to pay attention to that. And this is just some control data information. So it's worked out real well. Works good. Now both these 120 volt circuit and the 6 gauge, that's 12 gauge, and the 6 gauge 240 volt 60 amp circuit for the level 2 charge point. One of my concerns was with this long run, which is around 100 feet, maybe slightly more, was voltage drop. This Chevy Bolt can run the level 1 charger at either 8 amps or 12 amps. We run it at 12 amps most of the time. Gives you about 4 miles of range per hour, and was how much voltage drop I would get. I think I checked it running with the max current of 12 amps. We had a voltage drop of I think from 121 to 118, if I remember correctly. Wasn't much. I think it was acceptable. It hadn't been any problem at all working. Now, this one, I think I'll double check the voltages, but I believe when I checked it, running maximum current, which is 48 amps. The voltage drop on this level 2 running 48 amps was 243.7 to 235.8. So it was really no problem. This is where the conduit runs into the house. I've already covered up part of it here. And this ditch is a minimum of 18 inches deep. Some places I'll have to kind of hold the conduit down. I've also got a water pipe in there for a berry hydrant. But hand dug this to avoid killing these roots. A trencher would have just chewed right through them. I've got all my wire conductors laid out here. 3 12 gauge, 3 6 gauge. I've got a nylon rope to help for wire pulling at a later date. And got to get this set up here. You're wondering why the wires need to be wet rated. Imagine your conduit filling up with water underground. It would never come out. I'm going to run these wires over this pipe to kind of guide them down. And so I'm pulling them with this paracord. Hopefully that'll work. I'm going down into this 1.5 inch conduit, which goes over there. As I'm gluing these pieces together, I'm running some paracord down through the conduit using a fish tape to pull it down one section at a time. The reason for doing that is, you see I've got that in here. That's my fish tape reel. Is actually because I know the length of the paracord's 100 feet. I can get an exact measurement of how much wire I'm going to need to pull through this thing. So anyway, plus make it easy to pull the wires. You can run into a situation like I did where standard fittings on this conduit are not the angle you need. For example, this is 1.5 inch 45 fitting, but if I want it shallower, let me show you how to do it. I've got this extremely hot Seek 1 heat gun. I used it for greenhouse gas experiments some time ago, showing thermal emissions, but this thing gets really hot, up around 1,000 degrees F. So for example, if you want to flatten this thing out this way, like push down that way, this side would be under tension. If you heat the side that's under tension, you can soften it up with this and bend it where you need it. We'll try to show you how that works. This gets very hot, so I'd wear gloves and be careful. I'll just heat it on the tension side. It'll eventually get soft. Okay, there it goes. I gotta hold it here until it cools. So you really need another hand or somebody helping you. Okay, it took a couple passes at it, but it did flatten it out a little bit. And that's one way you can do it. I got probably a little bit hotter than I really needed here. I haven't tried the compression side. I think the tension side seems to work pretty good. So that's how you can change the angle if you need to. I'm pulling these wires myself. A little tedious, a lot of running around, but right now it's the only way I can do it. Almost got it, most of the wire pulled through this conduit. This is a little jumble out here, but see they're going into the house here, coming out of that conduit I just came from here. So I just pull these. I can't do it with one hand. I have to have two. I can't hold this camera and do it at the same time. Anyway, that's what I'm doing, working my way. I go under the house, pull some that way using that orange paracord. Seems to work. And this is where I'm pulling from under the house into that L body there, piling up my paracord here. But as soon as I've got this pulled through here, I'm going to go straight up into the breaker box. I'm using this lubricant I got from Lowe's. Lubricate up the wires real good. Makes it a lot easier. Hope you found this video interesting and informative. If you did, please like it, subscribe, and check out our other links. We'd really appreciate it. Thank you very much.